Good day, everyone. So now let's proceed to another way of evaluating the limit of a function by looking at the graph of y is equal to f of x. Now, the same example that we have earlier, through the table of values, we will graph the function. Consider the f of x is equal to 1 plus 3x, and we will look at the graph in the vicinity of x is equal to 2. So you can see the points approaching the level where y is equal to 7. So this is the graph. So we will separate or divide our graph in left side and right side, just as the same with our table of values. So as we trace here at the left side, we could see that as we approach to x is equal to 2, we could see that our y is equal to 7. Same here at the right side, as we approach to x is equal to 2, our y is equal to 7. So therefore, the graph clearly confirms that the limit of 1 plus 3x as x approaches 2 is equal to 7. Another example, the f of x is equal to x squared plus 1. We will look at the graph in the vicinity of x is equal to negative 1. So here is the negative 1. X is equal to negative 1. We will divide our graph in this part. Now, this is the left side of the graph. So as we approach to x is equal to negative 1, we could see that the value of y is equal to, here, the negative 2. We put, not negative 2, positive 2. Here at the right side, we will trace the graph. So as we approach to x is equal to negative 1, we could also be approach to the value of y is equal to 2 as well. So the y is the limit of the function. So therefore, the graph clearly confirms that the limit of x squared plus 1 as x approaches to negative 1 is equal to 2. So another example here is the function f of x is equal to x squared minus 5x plus 4 all over x minus 1. So we'll look at the graph in the vicinity of x is equal to 1. So here is the x is equal to 1. We will divide the graph into left and right. We could clearly see there's a white dot here. It means that at this specific point, there's no, the point is not existing. Okay, so you can see that the points approaching the level where y is equal to negative 1. So let's check. So as we trace it to the approaching to x is equal to 1, we could see that the y is equal to negative 3. Here at the right side, we trace the value, the graph, approaching to x is equal to 1. It also approaches to the value of y is equal to negative 3. Therefore, the limit of x squared minus 5x plus 4 all over x minus 1 as x approaches 1 is equal to negative 3, regardless if this particular point at x is equal to 1 is undefined or existing. Okay? Okay, for our last example, consider f of x is equal to x plus 1 if x is lesser than 4, and quantity of x minus 4 squared plus 3 if x is greater or equal to 4. So we will look at the graph in the vicinity of x is equal to 4. So our graph here at x is equal to 4, we will divide our graph. So as we traced here at the left side, we could see that the limit is here, and here at the right side we could trace is the limit is here. So the graph of x has no limits as x approaches 4, since the two separate parts of the functions move toward different y level. For the left side, it is 5. For the right side, it is 3. Therefore, the graph confirms that the limit of f of x as x approaches 4 is D in E, or does not exist. So again, if the limit is different from the left or not equal from left and not equal to the right, we declare that the limit does not exist, or T in A. Okay, so let's have another activity to check if you understand the topic. We will inspect by looking at a graph of y is equal to f of x. For number 1, limit of f of x as x approaches -2. Number 2, limit of f of x as x approaches 0. And number 3, the limit of f of x as x approaches 3. Okay, let's start with number 1. Limit of f of x as x approaches -2. So here is the graph. So x is at -2. We will divide our graph from left side and right side. So as we trace, we can see that we are approaching to y is equal to 1. The same from the right side. As we trace the graph, we see that as we approach to x is equal to -2, the y is equal to 1. Therefore, the limit of f of x as x approaches -2 is equal to 1. For number 2, limit of f of x as x approaches 0. So we are to determine the limit of the function here in the graph. So at x is equal to 0, here is 0. We will divide our graph. So as we trace from the left side to x is equal to 0, we could see that our graph approaches to y is equal to 3. Also, on the right side, we could see that the value of y is equal to 3 as well. Even though at this particular point the graph is undefined, but still the limit is 3. So the limit of f of x as x approaches 0 is equal to 3. Number 3, the limit of f of x as x approaches 3. So at x is equal to 3, we will trace our graph here at the left side. And by the way, we will separate our graph from left side and to the right side. So here at the left side, as we trace our graph, as we approach to x is equal to 3, our y is equal to 0. Here at 0. Now, from the right side, as we trace our graph to x is equal to 3, our y is equal to 4. Therefore, the limit does not exist because at the left side, the limit is different from the right side.